So we've talked about respiratory, cardiovascular, and muscular adaptations. And there's a few others that we're going to talk about. We're going to really kind of focus in for a minute on lactate. Okay, and so here are the objectives or outcomes for today. So remember we talked about lactate, and I want to reiterate, lactate does not cause fatigue, it does not cause soreness, it does not cause the burn. Instead, lactate is a buffer. Okay, and if you remember, lactate is produced when pyruvate builds up. Okay, in order for pyruvate to be formed, there needs to be oxygen. Okay, and so if there's no oxygen, that pyruvate is converted to lactate. And if we've got an excess pyruvate, then we'll also create lactate. Okay, and so pyruvate, we've got to get through the linking step, through Krebs, that sort of thing. And so if we're not able to get it through quickly enough because we don't have enough oxygen, then lactate will be produced. And this is beneficial for several reasons. One is it acts as a buffer for hydrogen ion. It can pick up that hydrogen ion and it can get it out of the cell. It can be used as an energy source, which we've talked about a little bit, and then it can be used to create glucose. Now, I want to be clear here. When I say it can be used as an energy source, like we can actually use lactate as an energy source. Okay, I'm not just talking about how we take lactate to create glucose, which can be used as an energy source, but lactate itself can be used as an energy source. And there's some evidence out there to suggest that the heart really likes lactate. It actually prefers lactate. Okay, and so lactate is a good thing, and hopefully that's one thing you take away from this class. So remember, lactate's correlated with fatigue, but there's a saying, if you've ever had a stats class, correlation does not imply causation. Or in other words, just because when someone's fatigued, they have high levels of lactate, that does not mean that lactate's causing the fatigue. Instead, these high levels of lactate that occur when we reach fatigue just suggests that your body's not able to use it. Okay, that your mitochondria is not able to use it, you're not able to put it through the Cori cycle fast enough, that sort of thing. And part of the reason why we're likely unable to use all this lactate is that we don't have enough oxygen floating around to take care of it. Okay, so many of the processes that go on in our body require oxygen. Lactate, utilization of lactate is one of them. Okay, now with training, there's a couple things that happen. Okay, one, we reduce the production of lactate, and two, we increase the clearance. In other words, we're able to use it, get rid of it, do something with it. And this leads to something called the lactate threshold. Okay, so notice that we've got this figure here, and in both cases, we've got a relatively, so on the x-axis, we've got intensity, and on the y-axis, we've got lactate concentration. Okay, red line is untrained, blue line is trained. All right, now notice that in both cases, it's this curve, right? So we've got a flat part and a steep part. And so we call this point, whoa, that line was terrible. We call this point right here, kind of this inflection point, that's much better. We call that lactate threshold. In other words, this is kind of the intensity where lactate production exceeds lactate clearance. Beforehand, I'm producing lactate, but I'm getting rid of as much as I produce, and so life is good. Well, with training, notice that this lactate threshold comes out to a higher intensity. Okay, so in this untrained individual, lactate threshold might be between, about 60, 65%. Well, in this case, after training, they increased their lactate threshold to 80%. There's a link between lactate threshold and aerobic performance. So as I increase lactate threshold, I improve aerobic performance, okay? And so this just shows that I'm being more efficient, I'm able to work out at a higher level, intensity, that sort of thing, okay? And so I also want to talk a little bit about RER. So after training, RER decreases for a given intensity. And so what that means is that for a longer period of time, we're relying on fats. And if I'm relying on fats for a longer time, that means I can hold on to carbs until I'm at a higher intensity. As we've discussed several times in class, fats are great. We've got an unlimited supply, but they're a little bit inefficient, or at least they're less efficient to use than carbs. It takes longer. It requires more oxygen. Well, low intensity, that's not a big deal. However, during high intensity activity, that's a big deal because things are happening. We have a great oxygen demand. We have a great ATP demand. We need to produce ATP as quickly as possible. Well, fat's not able to do that. But using carbs, we can create ATP faster. Now, if we get to where we can have a lower RER for a given intensity, that's great. That means we're actually becoming more efficient. Using fat can help meet our needs, and so we're able to go for a longer period of time. And so this kind of ties into VO2 max. After aerobic training, your VO2 max will increase. Okay, you'll have a better aerobic capacity, a better capacity to use oxygen. Okay, and I'm just going to make, this is kind of made up here, kind of is, kind of not. But what happens is we're going to see pretty big gains if we're less trained, right? So let's just say someone's VO2 max is 30, they start training, it's probably pretty easy, relatively easy to get to 50. But let's say that you're here, okay, you start here, we're just going to say this is 65. Well, to get to 70, it requires a lot of effort, a lot of energy, a lot of just working out, because you're really reaching kind of almost the theoretical capacity of your body, okay? We see this kind of thing all the time, right? So we see people that have been just sitting on the couch and they decide, hey, today I'm going to work out. And so just the act of getting off the couch, getting up and being active, they actually improve their aerobic fitness relatively quickly. Doesn't mean they're going to be all of a sudden exceptional athletes overnight, but they're going to see huge gains at the beginning. And it's actually one of the things that can be very frustrating for people is that the more they work out, the smaller the gains get to be, right? Think about what you might try to do as opposed to what an elite athlete might do. Okay, so we're talking like people in the marathon, elite athletes in the marathon, they're hoping to shave seconds off of their time of a 26-mile run. Whereas you or I would be willing to bet that if we ran a marathon and then we trained for 6 months and we did good training, we'd be able to take several minutes. And depending on, you might even be able to take an hour off your marathon time. Okay, and so these large increases come in untrained or less trained individuals. Now, I just want to throw this slide up here real quick. So notice that we've got increased VO2 max. Now, notice all of the things that can go into increasing VO2 max, right? And so there is a lot. And so we've got muscle, we've got cardiovascular, there's going to be some respiratory, among other things. This is highly integrated. And so it's not a simple matter of, oh, my heart gets stronger, my VO2 max is going to go up. That might be the case, but it's not the only way. And so we're going to focus on the last video with the respiratory system, cardiovascular, and muscular. I'm not sure why I started writing out respiratory there, but respiratory, cardiovascular, and muscular.